Okay, hello everyone. Welcome to the February community call. We'll have a little look through the recent releases today, one of which was rather sudden this morning, and then talk about how Singularity CE 4.1 is available packaged for Fedora and what's happening with Apple. And then there will be the usual chance to discuss anything else. So as I'm going through the call, as always, don't hesitate to shout out or raise your hand and ask any questions. There's also this GitHub discussion, which is in the screen share area, where you can log in and you'll be able to add any comments and things or ask questions after the fact. As usual, we'll post the recording to the Sylabs YouTube channel. Okay, so I'm going to go backwards a bit today because I'm going to talk about a 4.1.1 release before I get to talking about a 4.1.0 release. So this 4.1.1, let's cover this first. If you use many sort of Docker, Podman, OCI tools like BuildKit, or you directly use runc, you'll have probably been bombarded on GitHub or by other tools this morning about some CVEs which were found. So these are also somewhat relevant to Singularity. So I'll mention how now. The first thing is that the build kit dependency, which we use to build from Docker files into OCI CIF images, that's a new thing in 4.1, has a new version which addresses four vulnerabilities upstream. So this is also relevant to things like Docker, which you build kit as well. But because Singularity is now using BuildKit to do these Dockerfile builds, we've had a 4.1.1 release this morning, which pulls in the fixes for these. What the issue is here is that when we do a Dockerfile build, we have to start a BuildKit daemon in the background, and we submit the build to it, and it does it on our behalf before we pull the container back out into an OCI CIF image. And because BuildKit is a daemon which is accepting connections for instructions and things, there are various types of vulnerabilities that can arise. In the main, these things wouldn't be very serious for Singularity because you're building something, a Docker file, which hopefully you trust, and you'd almost always be building it as your own user. So the kind of scope to cause mischief with these is limited. But if you want to see more detail of exactly what they are, the links are here. And in 4.1.1, this has been patched by upgrading BuildKit. The other thing which is on people's radar this morning is a CVE in runc. And if we follow through that link, it's actually quite a long report talking about various attacks you can make to kind of escape containers that are run using runc. Now, Singularity does, in its OCI mode, use runc to run OCI mode containers if it's on your system, and the alternative crun is not on your system. So if you've got crun on your system, it'll use crun. Otherwise, it'll try to use runc in OCI mode. But we don't directly provide runc in this case. So if you're concerned by the vulnerabilities which are listed in the CVE, actually what you need to do is update your operating system packages which are providing runc as those are made available with the security fixes which came out at the end of yesterday. So that's what that is. It's also somewhat probably limited in scope for Singularity users, because if you go through and you scroll down and find some detail about how these attacks can be used, you'll note that the attack one here requires a privileged user to run a malicious kernel, malicious container image. Now, generally, you're not going to be using Singularity to run containers, OCI containers as a root. If you aren't able to update runC straight away, you can have a look at that and see what some of the mitigations and so on are. A lot of the time, it's not actually as serious for most Singularity usage as it might be with a runtime where you are habitually running things as root. So are there any questions on that before we carry on? All right. The other bit of better news is that 4.11 also includes a bug fix. We've talked about runC. The alternative crun, which is used if it's available in the system, has a bug in it. And this bug is triggered by Singularity. So we've got a workaround so that it doesn't crash for the versions which have this bug. So that's of interest to you probably if you're running quite a new distribution like a current version of Fedora or something which keeps up to date with crun. So you've got a new enough version to contain this bug. All right, so that was the 4.11 release. So we got the scary security bit out the way. What I really wanted to talk about first was to have a quick recap of our 4.10 release, which came out last week. So not far before 4.11. 4.10 and consequently 4.11 have a bunch of new interesting features, and we've touched on some of these over the past 6 months as they've been developed. But I want to recap on what we have available for you with 4.1, which might inspire you to upgrade. If you look on the release notes here on GitHub, you will see that we have 2 links to the admin guide and the user guide. These have been updated, and you'll find that if you go through to them, there's a section, What's New in SingularityCE 4.1, which is giving a summary. And there will be links out to relevant documentation for functionality which has been added, such as here. We've got a link out to the documentation about building from Docker files and to Docker style Skiff containers and so on. So definitely recommend checking out the what's new. But if we quickly flick through it, each of these things has been mentioned in previous meetings, but we have a kind of fix here where if you're using a cgroups v2 system and you're under certain circumstances, you kind of logged in through an interactive session with the scheduler, which doesn't set up the environment as if you were sitting at the computer or you SSH'd in. We got kind of a workaround for setting the environment properly so that you can still run containers as you'd expect in the OCI mode. We have the ability to use Fuse instead of kernel mounts in setuid mode, so that if you're concerned about vulnerabilities in the kernel file system drivers, maybe you're not able to update the kernel very quickly when patches come out because of the way your system is operated and how you have downtime and so on. You can now use settings in SingularityConf to disable kernel mounts, but they'll fall back to Fuse mounts rather than just giving a kind of error message like they did before in 4.0. There's been some changes to the registry login and logout commands where you can now give an alternative authentication file to store credentials. This is really mostly useful for people who are trying to use Singularity in CI workflows where perhaps they're using a tool which provides credentials in a authentication file that Docker can use or Podman can use. Well, Singularity can now use it too through this flag. We've looked before at keep layers flag, which allows you to create multi-layer OCI SIF images. That's where when we take an OCI container out of a registry, we don't flatten down all the layers, but we keep all of the layers in the OCI SIF file, and we kind of layer them up when we come to actually run the container. And that's the first step, as I mentioned before, toward being able to go into OCI SIF, but also back out again without losing any information, to go in the future back out to the standard OCI format. So in 4.2 or 4.3, you'll be able to pull down an image to an OCI SIF as a multi-layered image, and then push it back up into a registry for direct use with Docker or Podman or whatever you want. So Singularity won't be a sort of dead end for images in a mostly OCI workflow. You can push and pull like the other runtimes without losing layers or anything like that. The sort of headline feature really was with 4.1 was demonstrated by Omer a few months ago, which was building from Docker files. So I'll show that again in a second. This is exciting because now, as well as just pulling an existing OCI image down from a registry into a SIF file or an OCI SIF so you can run it with Singularity, you can start with the Docker file instead. So Docker files really are the most common way to define how to build a container. Up until now with Singularity, you could build a Docker file, push it to a registry, and then pull it down with Singularity. Or you could try and translate a Docker file into a definition file to build with Singularity. Well, now you can take the Docker file and build directly from the Docker file with Singularity, so you don't have those intermediate steps to deal with if you're trying to work with some software project which provides a Docker file but doesn't have pre-built containers and so on. The next point, the scientific file system is a project that exists to provide a means to package more than one application into a container and then use the different applications depending on some sort of arguments you pass to the container. And there are two real ways of creating these. SCIF functionality has been in Singularity for a long time, so you can put special blocks in a definition file when you build a Singularity container to enable this. When you're working with OCI containers, there's a different way of doing it. There's a tutorial to follow on that site, but you essentially embed a Python tool in the image, and that takes care of when you run the container, making everything set for the correct app that you've asked for. And there's now integrations. So the app flag, which we've had in our native mode, which works with SCIF containers built from definition files, will work in OCI mode with SCIF containers that were built using the kind of Docker-focused approach. And then we've got a couple of things at the bottom, which are just sort of cleaning up handling of temporary sandboxes when you run containers in certain ways. So it was quite a big release with some big kind of headline features. The Dockerfile build thing, something people have been asking for some time. So we're excited to get it out and look forward to feedback. Before I go and demo a couple of things, any questions on any of this? All right, I'm talking a lot and everyone else is quiet, but I will carry on and let's drop into a terminal and I'll show you the kind of couple of two biggest things that are in 4.1. So let's just recap the Docker file build then. In this directory, I have a Docker file. So it looks like something I can build with Docker or Podman or whatever. But I wouldn't have previously been able to build this with Singularity. We also have here some features in the Docker file which weren't previously supported by Singularity. So in the native mode, if you pull down an OCI image, something you built from this Docker file, and it had a user statement in it, Singularity would completely ignore this when it ran the container. So it didn't have the ability to do this. To become the test user, you just end up in there as dtrudge Sylabs, not as the test user as you expected. So with the OCI mode, we can actually support this now, but not only can we support images which have been built with this, but we can build images that have this type of stuff in there. So it's as simple as doing a Singularity build and turning on OCI mode. And then we're going to build to a container file called test.ocicif. And I'm building from the Docker file. We'll see that Singularity has spun up a special Singularity build kit D. And then it's used build kit D to perform the build. And it's pulled the resulting OCI image back into an OCI CIF. So if I have a look, I now have my test OCI CIF. It's very fast there because it's cached because I've run this before. But now we can run the resulting container and it works. We built it from a Docker file. And we'll also notice that if I show you the Docker file again, it was going to say, hello, who am I? And we've got hello test user. So it honored this user test user piece. So you can see that not only has going to 4.1 given us Dockerfile builds, but the OCI mode changes from 4.0 improve the compatibility with what you'd expect behavior to be from Docker or OCI containers. Any questions on the builds? All right, I'll show you the other thing, which might be of interest to several people, which is the Fuse container mounts in setuid mode. So if you aren't able to switch to the OCI mode, if you can't turn on user namespaces, but you're concerned about the potential for unpatched file system bugs or something in the kernel, you can now, in your Singularity conf file, find some settings here, okay, which are allow kernel squashfs and allow kernel extfs. And these control whether Singularity will mount a container image using a kernel mount or not. In 4.0, these settings were here, but if you turned it off, not a lot would happen. What we've done now in 4.1 is said that when they're set to no, we'll use Fuse instead. The default here is still yes. Not everything is supported when we're running using Fuse. Some particular situations with overlays and things don't work. And also you could have a performance penalty, although that would vary depending on the type of workload you have. But I've set them to no on this installation now, and I can still run in setuid mode my CIF image, and this is using the squashfs Fuse binary to do the mount out of the CIF image. And I can still run a very old EXTFS bare image, which isn't a SIF. This is like from early days of Singularity 2 before ended up in SquashFS even. Oops, I forgot to run. I can still run that, and it says again mounting with fuse, just to let you know, and the image runs correctly. So this is a nice change for people who might be a bit concerned and want to take a more conservative stance on whether they allow kernel mounts. That's how you do that. Any questions on that part?
Yeah, so the dash overlay doesn't with the ext fs file system doesn't work.
No, so we have implemented this in a particular way. So the fuse mount actually happens outside of the container runtime before the container starts up. And the reason for this is that by doing it this way, we don't have to invoke fuse programs using file descriptors kind of passed in to places in the runtime. So we don't have any dependency on something being Fuse 3 specific. The benefit here is we can do those EXTFS mounts with Fuse 2FS, which is currently Fuse 2 only, not Fuse 3. And we can use the fuse binaries which are in older distributions without issue. The downside of this is that, yes, some of the overlay stuff here, it's not wired up yet. In a future version, what we hope is that we'll either use the same approach, but we can do some additional mounts and kind of piece together the overlay. Or we could perhaps move to the alternative approach for using fuse mounts, which is to do things deeper in the runtime and pass file descriptors around once the fuse programs which handle EXTF file systems support fuse 3, and that reaches distributions more widely.
Okay. Did you notice that I have a pull request for that for Fuse 2FS I made, but to make it work with Fuse 3.
I'd seen I'd seen that you were starting to bundle stuff in Aptainer, but I thought it was only a patch there. But that's interesting
true.
to hear you've got a PR to make it upstream.
Right. It downloads the PR, which hasn't yet been incorporated, but it is there.
Okay, right.
And
yeah.
Another question I had. So now in user namespace mode, it's without, so say if allow set U8 equals no, will it also, and not using dash OCI, will it also use the squash fuse on the EXTFS?
Yeah, correct. So I can come back here, right, and I can put in -u and username to get it to user namespace mode, and it will do the same thing.
Okay.
And if you want, for whatever reason, to force it back to using a temporary sandbox, then you can do so. And also, if you have a fuse mount that fails, it's going to fall back to using a temporary sandbox automatically here. Unless for some reason you've disabled temporary sandboxes completely inside the Singularity conf as well, in which case you'll be out of luck. Hopefully that's clear. I should say that what we do to kind of make this work but keep things clean is quite complicated. So if you actually go and start a container and you have a fuse mount take place, and then you look on the host, you won't see an entry in the mount table for the fuse mount on the host, and you won't be able to go and look at that fuse mount on the host, but you will see the fuse binary running. So what we're doing is a little dance with mounting in one namespace, and then we are keeping open the mounted directory inside the container namespace, and doing a lazy unmount out on the host and so on, and tying it all together, and also tying it in with the potential ways that the container startup can fail and exit, so that the mount is cleaned up if the container process is killed, um, or so on. And this kind of tidying up of it is really what's fundamentally different to the previous experimental SIF fuse functionality we had before, where the fuse mount was visible out on the host always, and there were cases where it might not be cleaned up properly. Okay, so that's a rundown really of what's new in 4.1, with a couple of the big things demoed. Do we have any general questions, or any topics anyone wants to discuss? Okay, well, I must admit I was hoping to bring up a roadmap discussion for looking forward to 4.2, but with the security work this morning, getting out those fixes on the build kit dependency, that hasn't happened, I'm afraid. So that's something we can talk about in March. In the meantime, like I mentioned at the start, if you have any kind of queries about what's been presented here, or you comment or ask a question, then the GitHub discussion thread, which sort of announced this call, is a good place. Otherwise, we have the Slack channel and Google Groups too. So just thank everyone for coming, and hope to see you again next month.